China has successfully landed its first rover on Mars. The Tianwen-1 lander touched the planet's surface after surviving the treacherous descent by parachute.
A Chinese rover just found something on Mars that no one can explain. In 2021, China's Zhurong rover did something no nation has ever done. Landed on Mars on the very first try with no backup plan. But that was just the beginning. What Zhurong found 35 meters beneath the surface breaks every rule of planetary physics we've ever written. According to our best models, those layers should be physically impossible. This discovery changes everything scientists thought they knew about Mars, about when water disappeared, and about where life might still be hiding on the red planet today. But how does a rover find an ancient ocean when Mars hasn't had liquid water for billions of years? When Zhurong landed in Utopia Planitia on May 14, 2021, it carried something no Mars rover had used before in that location. A ground-penetrating radar that works like an X-ray machine for an entire planet. Now, this radar sends signals deep into the Martian crust and measures what bounces back. Different materials reflect the signal differently. Rock looks different than ice. Dust looks different than layered sediment. And water-deposited minerals create a signature that's impossible to miss. The rover rolled across the rusty surface, scanning as it moved. 10 meters deep, 20 meters deep, 35 meters deep into the ancient crust. And when scientists at the Chinese Academy of Sciences started analyzing the data coming back from Mars, they went silent. The radar had found 76 distinct layers stacked beneath the surface. Perfectly preserved horizontal bands that stretched for kilometers underground. But here's what made every planetary scientist's heart skip a beat. These layers weren't flat. They were tilted, sloping consistently in one direction at a gentle angle. And on Earth, there's only one natural process that creates this exact pattern. Ancient coastlines formed by waves depositing sediment layer by layer for millions of years. So, what story do those 76 layers actually tell? Well, each layer represents a distinct period in Mars's history, a time when dust storms buried everything in red sand. Scientists can read these layers like tree rings, with each band representing thousands or even hundreds of thousands of years. The Chinese Academy of Sciences concluded these patterns point to episodic flooding. Ice melted, water flowed across the plains, the water froze again. This cycle repeated over and over for millions of years. But the geometry revealed something even more dramatic. Utopia Planitia sits in Mars's northern lowlands, a massive basin that covers nearly 30% of the planet. The tilted layers Zhurong discovered slope consistently from the southern highlands down toward the northern basin. Well, that's the exact signature of an ancient shoreline. So Mars didn't have a few scattered lakes. Mars had an ocean covering a third of its surface. An ocean deep enough and stable enough to leave geological evidence that survived for 3 billion years. But radar images aren't the only evidence. The rocks themselves are screaming the truth. Zhurong carried spectrometers to analyze the chemical makeup of Martian soil. And these instruments can identify minerals by measuring how they interact with light. And what the rover found added another piece to the puzzle. Hydrated sulfates scattered across the surface. Salt crusts mixed into the dust. Minerals that only form in one environment. Liquid water. Not ice, not frost, not vapor. Liquid water that flowed, dissolved minerals from the rocks, and left behind a chemical fingerprint that's impossible to fake. These hydrated minerals act like a timestamp, proving water was present at specific locations at specific times in Mars's past. But here's where it gets really interesting. Those salt deposits have a special property. They lower the freezing point of water, just like salt on icy roads prevents ice from forming. This means that even after Mars's atmosphere thinned and temperatures plummeted, pockets of salty brine could have remained liquid beneath the surface. The minerals prove the water wasn't just there, they prove it stuck around far longer than anyone expected. creating conditions where life could have survived beneath the ice. For 50 years, scientists were certain about when Mars died. Zhurong just proved them wrong. The scientific consensus was clear. Mars lost its magnetic field billions of years ago. Without that protective shield, solar wind stripped away the atmosphere. Surface water evaporated into space or froze solid. By 3.7 billion years ago, Mars was dead. Cold, dry, lifeless. But Zhurong's discoveries shattered that timeline. The rover's cameras captured strange textures in nearby dunes, patterns that looked familiar. Cracked crusts, smoothed ridges, reshaped sand that showed signs of glacial activity. Periglacial processes where ice forms, melts, and reforms, leaving distinctive marks on the landscape. And when planetary geologists analysed these features, they realised something shocking. Some of these textures formed recently, not billions of years ago, not hundreds of millions of years ago, as recently as 400,000 years ago. Now, to put that in perspective, 400,000 years ago, early humans were already walking on Earth. While our ancestors discovered fire and crafted tools, Mars may have still had liquid water trickling beneath its frozen surface. The window for life on Mars didn't slam shut in the ancient past. It stayed cracked open, letting in possibility for hundreds of millions of years longer than anyone imagined. And that changes everything about the search for Martian life. But why did China land Zhurong in this specific spot? That choice wasn't random. Utopia Planitia is one of the largest impact basins in the solar system, and it's the same location where NASA's Viking 2 touched down in 1976. Viking searched for life using basic biology experiments, but 1970s technology couldn't see beneath the surface. It could only scratch at the dusty surface and wonder. Zhurong arrived with 21st century radar and a different mission. Map the subsurface, identify where the water was, figure out when. The landing site was chosen deliberately. Utopia Planitia sits in the basin of that long-lost ocean. Geologically stable, relatively flat, and rich in buried history. The perfect location to find evidence of ancient shorelines. And those 76 layers represent hundreds of thousands of years of environmental change. Flood events when Mars's wobbling orbit brought warmer conditions. Ice ages when everything froze solid. Each layer is a snapshot of Martian climate, telling the story of a world that transformed from wet and potentially habitable to the frozen desert we see today. Zhurong landed on an ancient beach, a beach where waves once crashed, where water met land, a beach that could have been the perfect environment for early life to emerge. So, here's the billion-dollar question. If Mars had oceans, did anything swim in them? On Earth, life appeared fast, really fast. Within just a few 100 million years of water becoming stable, primitive microbes were already thriving in Earth's oceans. The ingredients for life are surprisingly simple. Liquid water, energy from the sun or chemical reactions, basic organic molecules, time. Well, Mars had all of these early in its history. A thick atmosphere, warmer temperatures, liquid water pooling in vast basins like Utopia Planitia. If life emerged there, even simple single-celled organisms, they would have faced a slowly dying world. The magnetic field weakened, the atmosphere thinned, temperatures dropped, oceans began to freeze and evaporate. But life is stubborn. Martian life, if it existed, would have followed the water downward, retreating into subsurface aquifers as the surface froze, surviving in pockets of salty brine protected by layers of rock. The discovery doesn't just suggest Mars could have had life, it suggests life might have survived far longer than anyone thought possible, increasing the odds that evidence still exists, buried and waiting to be found. Zhurong's mission is over, but the story is just beginning. The rover entered hibernation in 2022 when Martian winter arrived and dust covered its solar panels. But the data collected in just over a year of operation will fuel research for decades. And China isn't finished with Mars. Around 2028, the Tianwen-3 mission launches. This is a complete sample return architecture. Land, collect soil and rocks from those 76 buried layers, launch back into Martian orbit, rendezvous with a return vehicle, bring actual pieces of that ancient coastline back to Earth. If successful, scientists will hold Mars in their hands. They'll look for patterns in the minerals that match what life produces on Earth. And if they find anything, even a single molecule suggesting life once existed, it would be the most profound discovery in human history. The samples returning in 2031 might answer the ultimate question: are we alone? And if life existed on Mars, what does that mean for life's prevalence throughout the universe? Zhurong spent just over a year on Mars, and in that time, it turned a frozen, barren landscape into an open book. But the rover only scratched the surface. Literally, the real answers are deeper. That's why Tianwen-3 matters. That's why sample return matters, because the evidence is already there. It just needs to be brought home.